In this video, I want to see if I can make any conclusions about some general logarithm properties. And we're going to do this by evaluating some. Let's start with ln of 1. I'm going to set this equal to x. Since this is an ln, we know our base is e. We need to raise it to the x power, and that should be equal to 1. Well, in that case, x is 0, since e to the 0 power is 1. If I look at log of 1, the fact that I don't have a base here means my base is 10 to the x power is equal to 1. Well, 10 to the 0 power is 1, so that would once again be 0. We could also look at something like log of the square root of 7 of 1. In this case, my base is the square root of 7 raised to the x power is equal to 1. And once again, we get that x is equal to 0. In general, log base b of 1 will be equal to 0, no matter what your base is. And this comes from the fact that anything to the 0 power is 1. So if we ever take log of 1, we know the answer should be 0. For my next one, I want to start by looking at ln of e. The fact that this is an ln means I'm going to have a base e raised to the x power is equal to e. So that tells me x is 1. If I do log base 13 of 13, my base is 13 raised to the x power is equal to 13. Once again, I have x equal to 1. If I do log base 3 of 3, my base is 3 raised to the x power is equal to 3. Once again, x is equal to 1. In general, log base b of b is equal to 1. So if the base and the thing I'm taking the logarithm of match, I know my answer must be 1, since anything raised to the first power is itself. For my third property, I'm going to look at log base 3 to the 10th. We have our base is 3 raised to the x power is equal to 3 to the 10th. So in this case, x is equal to 10. If we have ln of e squared, the fact that I have an ln tells me my base is e raised to the x power is equal to e squared. So x is 2. If we look at log of 9, log base 9 of 9 to the root 2 power, my base is 9 raised to the x power is equal to 9 to the square root of 2 power. X is equal to the square root of 2. In general, log base b of b to the x is equal to x. If my base of my logarithm and the base of the exponent match, I'm just left with the actual exponent. And this lines up with what we know of logarithms. We know that a logarithm is the inverse of the exponential. So the logarithm and the exponential should cancel each other out, and I'm just left with the exponent. This one's a little bit trickier. What happens when I raise something to a log power? Well, let's start by saying log base a of 3 is equal to x. So this I can rewrite as a to the x. Well, converting, this would be a to the x power is equal to 3. So a to the x is equal to 3. These were the same in the first place, so this simplifies to just a 3. Let's look at another one. This time I have 5 to the log base 5 of c squared plus 4. So I'm going to start by letting log base 5 of c squared plus 4 be equal to x. That tells me I can rewrite this thing as just 5 to the x power. Here's my 5 raised to the x power should be equal to c squared plus 4. That tells me this thing is just equal to c squared plus 4, so my solution is just c squared plus 4. Let's try to do one more. This time I have 10 to the log of a squared plus b squared. Once again, I'm going to start by just letting that exponent be equal to x. So I can rewrite this as 10 to the x. Converting this, I don't have a base, so that tells me it's 10 to the x power is equal to a squared plus b squared. So this is equal to a squared plus b squared, which is what I needed, and I have my solution. In general, b to the log base b of x is going to be equal to x. As long as the base of the exponent and the base of the logarithm are the same, they'll cancel each other out, and I'll be just left with this term right here, which is the x term.